Hi guys, welcome back. It's steeljan here, and today I'm taking a look at the EGO-C Twist battery. Now I've had this thing for like over a month now, and I bought it from Texas Select Vapor. I wanted to buy it from them because guys like Shannon Herod, I liked what he said about them. Big Ice Dog even likes them, even Vaping Monkey. So I thought Texas Select Vapor. So I had to wait for him to get this silver one in. I got no volunteers to send me one to review. So if I was going to buy it, it was going to be the stainless steel. So also I've got a stainless steel cartomizer on here to make it look nice with my nice drip tip that I had. And then here is the stainless steel cone that I also bought from Texas Select Vapor for like $2.50. And I think it just cleans up the look. So what I like about this, so when I first got this, I thought, oh my God, this is great. And I thought, well, wait a minute. If I'm going to say, oh my God, it's great on a video, I need to do more testing. I need to really put it through the torture tests. Sorry, my doggy's barking. It's a home movie, folks. So yes, it has the variable voltage. You twist up. That's why it's called a twist. You vary the voltage up on the dial. And it has the 5-click on, off. Off. On. It says it has short circuit protection. Don't try this at home, but I'm going to short positive and negative out with my screwdriver. Nothing happens. Let's see if it still vapes. I've already done this. And so yes, it is short circuit protected. So now I wanted to know, first of all, let me tell you something. If you're going to get one of these, make sure it says Joyetech on it. Joyetech is who's making these. Now, when Joyetech usually hits with a fantastic product, the counterfeiters come up pretty quick, and the quality may not be as good. So buy somebody that you know is selling genuine Joyetech equipment and not a counterfeit thing. You know, we don't want any mishaps with these batteries going on, right? So here we go. I'm going to show you a bunch of stuff. This is going to be a long video. I apologize up front. And something else, when I was editing my segments, I noticed that, just in editing my segments, I noticed that, yes, I come across as kind of not, I come across badly sometimes, poorly sometimes. And I just don't know why. It's just, that's just me. So all the people that hate me, I understand it, but I apologize up front for anything you don't like about this video. So one of the first things I wanted to do was I wanted to find out if this is genuinely a 1,000 milliamp battery, 1,000 milliamp hour battery, because very often, especially in the last year or so, we get something that says how many milliamp hours it is, and it's not really, you know, like that. See, here I go again. I'm sorry, I know you hate me. So I thought, how can I find out if this is a 1,000 milliamp hour battery without taking it apart? And I was thinking, okay, if I wanted to know how much this glass holds, and I know how much water's in this cup, and I pour this water into this cup, and if it fits, I'm pretty sure I know how much water this cup holds, right? Glass. So I thought about something. I had gotten this Tenergy watt meter. It's a remote control, you know, RC aircraft watt meter, and it's for genuinely it's for testing batteries and stuff for RC enthusiasts, remote control aircraft and stuff enthusiasts, to make sure their batteries are okay. So what I did with this was I bought this back when I heard the Evolved DNA was coming out, and yes, I have a couple of Evolved DNAs. That's beside the point, but I do have them now, and I'll be modding them in the future. But so when I knew that was coming out, I thought I got to have something to be able to see the watts with that. So I got this watt meter in anticipation of that. And so I was thinking when I was doing my EGO-C Twist review videos, torturing, excuse me, I thought, okay, I wonder, first of all, I wired it for USB so I can power it. It'll run without external power, but it uses then the battery that you're testing as part of its power. So to eliminate that, I created a cable and wired it up for USB, and then I soldered onto these 14 gauge wires on the end, connectors, And I thought to myself, what if I use this watt meter backwards? instead of watching it use a battery, what if I watched it charge a battery? If I get 1,000 milliamps or 1,000 milliamp hours or better in the battery, I can probably say, okay, if it would only hold 650 milliamp hours, I'd say, we're getting shystered. So let's look at that. Let's see what happens when I charged the battery. Okay, so here is the watt meter, and the way I've got it set up is I've got the Joyetech charger as my source, and my load is going to be this Ego C Twist battery to charge, and I want to watch it charge. And so I'm plugging it in right now, and we've started charging. So we've got 420 milliamps going in, 430, and 3.46 volts. And around here we'll be able to see the milliamp hours count up. It'll be AH. That's what we're looking for. There it is, AH. There's already 8 milliamps in there, milliamp hours. So now I'll take some video every half hour and we can watch this battery charge. Okay, this is 30 minutes into the charging, and we've got it's accepting 420 milliamps, and it's at 3.88 volts, and so far it's accepted 181 milliamp hours. So this is 1 hour into charging, and we're doing 410 milliamps at 3.93 volts, and it has accepted 408 milliamps hours. So now at 1.5 hours in, we're at 4 volts, 4.01 volts charging. It's charging at 410 milliamps, and it has accepted 609 milliamp hours. Okay, this is 2 hours into the twist charging. It's taking 380 milliamps. It's taking it at 4.10 volts, and it is so far accepted 818 milliamp hours. Okay, now we're 2.5 hours into the charging. We're at 4.26 volts. It's accepting 320 milliamps, and it has taken 995 milliamp hours so far. 995 milliamp hours. Okay, rockin'. Okay, so it's 2 hours and 50 minutes in, and now this battery's doing what I call its long time off, and then it comes back on again for charging. And it'll do this for me, for every charger I've tried it with. It'll be green, and then it will suddenly go back to red again. And it'll keep this, it'll keep doing this, so you can watch this and you can see if it goes red again, because you'll see numbers pop up for it continuing to charge. Let's see what its milliamp hours finally were. .030. Okay, so it accepted 1,030 milliamp hours. And I'm going to say, in my opinion then, I guess, if it holds 1,030 milliamp hours, does that mean it's a 1,000 milliamp hour battery? I just know if it accepted only 650 or 900 or something, then it wouldn't be 1,000. So that's my best guess. And in future videos and future tests, I'll find out how true that is. Now, for anybody who's new to this and don't know, I'll just go briefly here into putting your battery on a charger, take a tissue and clean any excess e-liquid out of the inside of your charger, of your battery, and make sure your charger's clean. Use only the Joyetech charger. It's a 4.2 volt, 420 milliamps on the specification. And you screw the battery on, and you just screw it till it's snug and don't cross thread it. Just snug. Then plug it into USB. And you can plug this into your computer, but since you saw the charge currents there, it's going to be running, it's going to be taking like 424 and 30 milliamps. So if you've got a lot of other things plugged into your computer, use an external USB wall charger to plug this into. Just, you know, so you don't overtax your computer. So let's look at this. I know I'm not usually a charts and graphs person, but I thought this would be fun. This is the chart of the voltage and the current as it was charging, and you can see it gets over here to where it can't accept any more charge, and boom, then the charge current stops. And then here is a look at that accepting milliamp hours. Now here's the milliamps going in, and then boom, can't accept anymore. But here's the charge current, the milliamp hours going in. Milliamp hours going in, milliamp hours going in, boom, until it stops. I thought that's so cool. I wanted to show you that. So, next thing I want to talk to you about on this is, I've got my notes here. Oh yeah, this you're probably gonna fuss at me about. This is, how does buck boost work? Because this is a buck boost technology, and I've just haven't gotten into this yet to show on a video because I just couldn't figure it out. So I couldn't figure out how to explain it to here's my little buck boost talk. Okay, so let's first look at Ohm's law. We all know EIR, right? Don't freak out if you don't, just follow me. E is voltage, that's electromotive force. So volts divided by resistance equals current. Current divided by resistance equals voltage. It's Ohm's law. And this goes for DC, direct current. That's where you have a level in a battery, and the current coming out of that, the voltage is steady. So if we looked at it on a graph, the voltage is steady. And if we looked at the graph of the current is steady. Direct current. That's why we say 5 volts DC, 4.2 volts DC, direct current. Everything's smooth. Ohm's law. We get into a difference here though when we are talking about using something like the Ego C-Twist boost buck circuit. So let's take a look at how that works. I've been racking my little pea brain trying to figure out how I could visually show you this without being technical. And this is kind of probably going to make people in engineering or electronics giggle a little bit, but this should do the job for anyone who's curious to know how it works. Now this half cup of water in this measuring cup I'm calling a voltage, 5 volts. No, let's say it's a lithium battery, 3.7 or 4.2 volts. Which one would you like? Oops, let's say it's 3.7 volts. Now, as you can see, when I poured the half cup of water into this bottle, it looks like much more. And that's how a boost circuit works. It takes a quantity and manipulates it through an electronic circuit to make it look like more to the exterior circuit. So now we've made this look like, this 3.7 volts now looks like 5. I can't talk today, folks. So now we'd have 5 volts from 3.7. It's just boosted up. Actually, it's going to be 4.8 because we're going to lose like 0.2 volts to the circuitry that's going to convert it, that's converting it. Okay, So now let's look at something. Let me take my magic marker. Let's look at this. That's our boosted up to 5 volts. Now watch this. If I wiggle this, let me get my pen out. Now if I wiggle this, where does the voltage look like? Let's see, I'll get my piece of tape around here. Where does the voltage look like now? It looks like it's about there. So you see, instead of it being the 5 volts that we boosted it up to, now if I wiggle it, it actually looks like a lesser voltage. Maybe all the way down to where it looks like 3.2. So that's the two things we're looking at in the EGO-C twist battery with this buck boost circuitry. I'm going to have trouble with that. Okay, so let's think about that for a second. Here's our cylinder of water, which at its steady state we're calling 5 volts. And if we poked a hole inside of it, the stream of water would come out a nice, even stream of water. And it would depend on the resistance we stuck on it, how much it keeps it from flowing. Then we would quantify this. If this was a 2.5 ohm cartomizer, then this would be 5 volts divided by 2.5. This would be 2.5 amps. Okay? Nice and smooth. But when we're jiggling it, when we set up a waveform inside of here so that we can make it look like something different on the output, then things change. This becomes this, because we dialed it down to 4 volts. Or let's say we dialed it all the way down to 3.2. We dialed it all the way down to 3.2. Now, actually, hang on a second. It's going to look more like this would be the average. Like that. Because we set up a waveform. When we poke a hole in the side and take the current out, the current is also going to be a ripple. It's not going to come straight out. If you could imagine, if I poked a hole in this and went like this, and we watched the water, it would spurt out in a little wave. It would spurt out. It wouldn't just run out, it would spurt. Same thing. So our voltage on an oscilloscope is going to look like this. It's going to look like this, with an average voltage of 3.2 volts. If we could also look at the current, well, hang on, let me blow this up a little bit. Let's take one of these waves. This is our voltage. Coming out, something like that. Well, our current is going to do this. And the power, the watts, which is voltage times current, is going to be here. And the equation that we'd use for this is not Ohm's law anymore. Our current, this is current, and this one is voltage, electromotive force voltage. It's going to be, boy, is that a sloppy wave. It's going to be out of phase. And we have to take into, in our equations, the delta change of phase between the current and the voltage. So it gets a little tricky. And the cartomizer that we put on out here, it may be 2.5 ohms. But we would no longer calculate that as a resistance. it actually would be calculated as an impedance, which takes into account the phasal relationship between the voltage and the current. So how we measure these things and how we see them, you can screw on your little voltmeters and things like that, but you're not actually going to see the true information. You need something that is able to take into account the deltas, the phasal relationship between the voltage and the current. So that's how they're doing it in the Ego-C Twist. They're taking a battery, they're putting it through this boost buck circuit so that it looks like more voltage than the battery is. But then if they wiggle it, when you dial the Ego-C Twist down to a lower voltage, if they start wiggling that and making a waveform, now we get into a phasal relationship. And so we can make it look like 3.2, 3.4, 3.6, and then on up to 4.0, 4.2, 4.8. And 4.8 is going to look just about like a steady state. And I'll show you that. Okay, so now we want to look at the phasal relationship and see if we can use this Turnigy. This is something I wanted to see too. Can I use the Turnigy to see those volts, amps, and watts the same as I would do on an oscilloscope? My big oscilloscope, my bench oscilloscope, does not do automatic measurements for me, and hand calculations would be so tedious on the camera. So now we're going to go with one of these little open source DSO Nanos. And let's take a look at that video. Okay, so I've got one of these little oscilloscopes here. It gave me really crappy measurements right out of the box, but this is an open source project, so I've downloaded the latest hobbyist firmware for this, and also I calibrated it against my bench oscilloscope. Oops, my bench oscilloscope. And so now what we want to look at is, so I mean it's not going to give great measurements, but it's going to give me okay for the experiment I want to do here. So what I did was I've set this now so that up in this little upper right hand corner it's going to give me the average voltage. In other words, I don't have to go look at a measurement. It's just going to display it right there, and I've tested it a few times. It looks like it's going to be pretty accurate for me. Now what I'm doing in this experiment, I've got the Ego-C Twist battery, and on the load side, on the source side, and a Bogue 2.6 ohm cartomizer on the other side. So now that's my load, and so now we're going to see the waveform that it's going to generate, and then we'll see, I'm going to show you that this Turnigy meter is even going to give me the correct average voltage. In other words, the calculation of what the wave would be if I sat down and hand calculated it from an oscilloscope measurement. This is going to be good for that. So this gives me a really good feeling about this Turnigy watt meter to use for analyzing things. So here we go. This is on the Ego-C Twist's lowest setting of 3.2 volts. You see the waveform here, kind of a sawtooth. And look, we got 3.22, 3.2. These are the same. So that worked out well. Let's crank this, let's put the Ego-C Twist up a little bit. So I've got it roughly set on where I think the battery should be at 3.7. And let's push a button. Okay, now we see the wave pattern vary more. We've got 3.55 here, 3.57 there, very close. So here it is on the 4 volt setting. It says 3.923, 3.923. So yes, the watt meter's working. Let me capture, oops, let me capture this image on the scope, and we can go down here and take a look at it. So now, yeah, you can see how this waveform is changing. Now, it looks very similar on my real oscilloscope. I mean, you know, my bench oscilloscope, sorry. This is 4.4 volts on the twist. 4.2, 4.3. So this is at 4.8 volts. We got 4.8589. Look, they are running, they are staying very much the same up here. So, ta-da, that's it. I know. A bunch of you are going to say, yeah, but I like to vape low resistance dual coils. Let's quickly take a look at low resistance dual coils. Okay, so if you want to see all those measurements at once, here they are. And you can pause the video and look at them if you'd like. What I notice here is that it looks to me like 9 watts is about the limit. We've got, no matter what you set it on with low resistance dual coil, you're not going to get your voltage that you wanted to dial in. The settings for the single coil cartomizer at 2.4 to 2.6 ohms, that all looks good. And it's a very satisfying vape. I did put a note in there, and if you paid attention there, when you get up in this 4.4, 4.8 volt range, when you're dialing it in, after 4 seconds it drops really fast. So 4 seconds, as long as you're good with a 4-second vape, you're going to get a good one. Now, let's talk a little bit about how this lasts over time. Now, this is the little brochure that comes with the battery. And by the way, this battery has 10-second cutoff, which is a really long cutoff. But like I said, at the higher voltages, it's going to drop after 4 seconds. So the battery's going to shut off, you know, it's a 10-second vape, and then it'll stop until you let go of the button and turn it back on again. But on the back of the little thing that comes with the EgoC twist, they have this little chart, and I blew it up and printed it out, and here it is. And I have one little problem with this chart, and that is, you see where it says puffs down here? Well, I actually tested this, and it says the max up here is 200 puffs. Well, the chart goes up to 200 puffs. That needs to be times 10 in my book, times 10. And I tested this by, I used my Ultimo that I've shown you a lot of times. This actually has a puff counter on it. And what I did was I sat vaping this thing. Every time I took a vape, I pushed the button on this to up the puff counter. And I just did this over and over again. Until I found it out. And so I always got about almost 2,000 puffs on mine, not 200. And for me, that lasts, this battery, 1,000 milliamp hour battery with my, this is a 2.2 ohm cartomizer on it. I was typically vaping this, what is this? It's a 2.6 ohm or 2.4, 2.6 ohm Phoenix is what I like, and I had this dialed in at 3.8 volts or 4 volts. I did 4-volt experiments and 3.8-volt experiments, and the battery lasts 12 hours for me. So yeah, nearly 2,000 puffs. However, I got some video on this, but I think I've just videoed you to death. I do see, so if we take and say this is 12 hours across here, then right in here would be about an 8-hour mark. And when I was doing my experiments, that's about when I felt I'm sitting there vaping along, vapey vape, and you feel that little drop right about here for me, right about the 8-hour mark. So I measured that, and where is my thing? Okay, so on mine, when I had it set for full 4 volts and it was fully charged, it actually measured 4.3 volts. And then 8 hours in, when I felt that little drop, I went and measured again, and it was 3.82. So yeah, that's that little 8-hour drop for me. And I'm figuring it's right at this point of the Joyetech curve. And you know, on their Joyetech curve, they actually say on there, on the little paper that I've now lost, they actually say that their graph is made with 4-second puffs. It's at set for 4.8 volts with a 2.2 ohm atomizer, and each puff lasts 4 seconds. So I know why. It's because after 4 seconds at 4.8 volts, the voltage goes meow like a rock, drops like a rock. Oh, let's do the comparable size thing. Here it is next to a lava tube. Of course, I've got the cone and the thing on here. And here's next to a 900 milliamp hour Ego battery. Here it is next to, how far do you want me to go? Here it is next to Darwin. Is that good enough? Oh, here it is next to a Go-Go. The Vape the Rainbow from Texas Select Vapors, I like. Thank you, Brett, over there. It's a little too skittly for me, but I like the Vape the Rainbow. The battery, how long it will last, as far as longevity of it, months, years? I'd probably think months, but I don't know. But as far as do I recommend this, I would say yes, I very much do. And thank you again, Estara, for sending me your broken one that I got to fix. Anyway, that's on that previous video. That's it. I would like to see this come out for in a kit, which I see folks like Inhaler and I don't know, Alt Smoke. There was several of them I see are coming out with kits. If a beginner's going to use this, which I think it'd be fine for a beginner, it needs to come in a kit form with everything included, and that ensures that a beginner gets the correct charger. You need the correct charger for this. An incorrect charger on any battery is a potential for danger. So for me, the Ego C Twist gets total thumbs up. I'm using it. I'm glad I got it, and I want a pink one. Okay, guys, support CASAA.org to help fight the vape bans. I really can't talk anymore. Really can't. And until next time, guys, happy vaping. I'll see you next time. Steeljan out. Steeljan.